Hello everyone, you are welcome back to this class. So we continue from where we stopped in our last video. So which I promised that we're going to continue from multiplication rule under probability. We are seeing under probability. We still have a lot of work to do here. So in this video, we'll be looking at multiplication rule, and under multiplication rule, as I've explained earlier on, is multiplication. So when you have and in probability means multiplication. So we have two concepts that I want to look at in this video. And what are the concepts? The concept we have independent events and dependent events. So how do you identify that an event is two events are independent and uh, two events are dependent? So that is what we want to look at first. So the first one is independent events. So two events A and B are said to be independent if the occurrence or non-occurrence of A does not affect event B. So when things are independent, it means they do not depend on one another to exist or to happen. For example, if doing an action will affect the occurrence of an action, so such event is not independent, it's dependent, because the occurrence of one will affect the occurrence of the other. But in this case, the occurrence of one will not affect the occurrence of the other. I hope that is clear. So that is what refers to as independent events. So now, having known that, let's now look at examples on uh, how to solve problems of independent events. Don't forget that two events are said to be independent if the occurrence of one does not affect the occurrence of the other. So that is what refers to as an independent event. But before we look at that, so we need to first of all look at some rules. All right, we look at some rules that's guided. So let's go back to this place. So two events are independent. Let me put my pen. So two events are independent if the occurrence of one does not affect the occurrence of the other. So mathematically, so this means that, excuse me. So mathematically, so it means that, excuse me. Okay, so it means that probability of pen probability of one, so which is probability of A and B, A and B. So this is where the rule comes in. And means multiplication. So it means that probability of A multiplied by what? Probability of what? Of B. So that is just the rule. So it's the same thing as probability of A intersection probability of B, which is equal to probability of A multiplied by what? Probability of what? Of B. I hope that is very clear. So we can then move to examples now. So let's look at this example. So examples, the first one is a box contains two red balls and four blue balls. A ball is drawn at random. One ball is drawn at random from the box and then replaced from the box and then replaced before a second ball is drawn. So this one is just typo error here. So let's and then replace before a second ball is drawn. So find the probability of drawing three red balls. So find probability of, so you can see that when you pick one ball, so you are going to replace it before solution now. So let's know the total number of balls. So sample space here will be what? 2 plus 4. And that gives us 6. So a ball is drawn at random from the box. So one ball is picked. So what's probability of picking? The first one you are going to pick is red. So probability of red here is what? Red, that is 2 over 6, all right, which is 1 over 3. Because it is replaced, the sample space will not change. So in that case, probability of picking 3 red, but that probability of red and probability of red and probability of red. So that means 1 over 3 times 1 over 3 times 1 over 3. So this is independent. So the occurrence of the first ball does not affect the occurrence of the second ball. The occurrence of the second ball does not affect the occurrence of the third ball. So that means the sample space will still remain since it is with replacement. So in that case, our answer will then be 1 all over what? 27. I hope this is very clear. So that is that on the first example. So let's look at the second example. So the second example here, example 2. A bag contains 3 black balls and 2 red balls. A ball is picked at random from the bag. So the first thing we're going to do here first, so let's divide this into 2. So solution here, solution, so total sample space, the total balls in the bag, so will then be 3 plus 2, 3 plus 2, that is what? 5. Because we have those black ball and the red ball. A ball is picked at random from the bag and then replaced. A second ball is picked at random again. What's probably that they are both black? They are both. You know, when you pick the first one, so they are both black. The first one, both black. Both black. Probability of both black. So we then be probability of black and what? And probability of what? Black. So since it's with replacement, so black ball here is 3. That's 3 over 5 times 3 over 5. So that gives us 9 over what? 25. Then for the second one, so one is black, the other is red. So that means probability of black and probability of what? Red. So that means we have probability of black, which is 3 over 5, times 2 over 5, which is probability of what? Of red. And that's going to give us 6 over what? 25. We can reduce it to the lowest term. I hope this is very clear. So that is that on independent events. So we are now going to move to dependent events now. So what is dependent events? So let's look at that one. So dependent events here, excuse me. So dependent events. So 2 events are said to be dependent if the occurrence of events A of one affects the occurrence of the other one. I repeat again, if the occurrence of one affects the occurrence of the what? Of the other one. So we say that the 2 events are dependent. So then probability of A and B will then be probability of A times probability of B slash A. So that slash A means that given that A has occurred. So that the probability of B, given that, that means you are saying that probability, if you have this, sorry. So probability of, so when you have something like this, probability of A slash A. So that means, it means that probability of B, given that A has what? Has occurred. So this is a condition. You understand? So from here now, we will look at example and see how questions usually comes in this form. So this one, when you see without replacement is reference to these events. So that is dependent events. So with replacement, that is independent. So since it's not, they are not going to replace the item, the event, so that means it will affect the sample space. So the sample space in the bag must have reduced. So let's look at example before. Let's look at example. All right. So example under this one. So we have this. A bag contains 9 identical balls, out of which 3 are blue, 2 are white, and the remaining are what? Red. So in this case, the sample space here is 9. So number of blue is 3. Number of white is 2. And the number of red. So which is the remaining one? So 3 plus 2 gives 5. 9 minus 5 gives what? 4. That is 4. So if 2 balls are drawn at random, one after the other, what is probably that both of them will be red if there is no replacement. This condition, if there is no replacement, is a condition, which means the sample space will be reduced from 9. So if you pick the first one and you get red, you are not going to return it. I hope I'm making sense. You are not going to return it before you pick another one. So you have to pick another one. So from the one you are picking again, you are picking out of how many now? Out of 8. So to solve this is going to be probability, the first one, probability of red. Excuse me. So probability of both red, probability of red and red, probability of red and red. So means, so probability of red times probability of red, given that red has occurred, that is, one has been removed. So in this case, we are going to have it to be probability of red there is 4 out of 9. And when you are picking the second red, the total number of balls in the bag has reduced from 9 to 8 because you did not return the first one you picked. So this will then be what? It will remain what? So that means the number of red balls in that bag has reduced to what? To 3. While the total number of balls in that bag is now what? Is 8. You can see the logic. So if care is not taken, you miss it. I'll repeat again. When you pick the first red, when you pick the first red ball, right? When you pick the first red ball, you have reduced the number of balls in that bag. The number of balls in that bag has reduced when you pick the first red. Now, because you did not return the first one you picked, right? That means the number of red balls has also reduced from 4 to what? To 3. So also the total number of balls in the bag has also reduced from 9 to what? To 8. That is why we have it to be what? 3 divided by what? By 8. I hope I'm making sense. So in that case, our answer here will then be 4 multiplied by 3. All right, 4 multiplied by 3, which is 12. Then 9 multiplied by 8, which is what? 72. So we can reduce this one further. 2 can go here, that is 6. 2 can go here, that is 3. 1, that is 36. So that means we have 1 all over what? All over 6. So the answer is 1 over 6. I hope this is very clear. So that is that under uh, product rule, which is multiplication rule, uh, we have talked about dependent and independent event. So this is where we are going to stop in this video, and we are going to call it a day now. I'm going to, in the next video, we are going to look at some other concepts under probability. We want to look at more examples. There are some other conditions that we want to look at again. Then we'll end the class under probability, move to another topic entirely. So I hope you find this video helpful and useful. If you are new to this channel, don't forget to subscribe and make sure you turn on the notification bell so that anytime I release video like this, you'll be able to be the first to get access to it and benefit from it. So we're going to meet in our next class. Bye for now.